Hello, this is Dr. Oz. In this video, I would like to share with you simple linear regression. All right, I will just drag this, control drag my worksheet, and I will call this one as simple linear regression. Again, all I'm gonna do is delete my forecast column, and I will make my forecast here. By the way, I forgot to change the headings for my previous videos. Please forgive me for that. You can just delete this part and that says forecast. And so I will just make my forecast in the column D. All right, so I'm gonna make a forecast based on the revenue again. So what I'm gonna do is, let me show you the data, highlight this. If I insert a line chart here, sorry, not line chart, let's do scatter chart. If I include a scatter chart here, you will see that the scatter chart for this company looks like this. Again, looks like the data was here. Probably, again, they did some mergers and acquisitions here. And all of a sudden, the revenue jumped up. So how can I use a simple linear regression here? What you could do is click on your chart. And then here you will see the plus. And you can click on this. And then you can include a trend line here. And there are different options. What I'm going to do is click more options, and I will choose linear regression line here. And as you see, this is the best line that fits with my data. And obviously, I underestimate these and overestimate these because there is something significant change happen here that linear regression will not be able to handle it. Excuse me. And let me just show you two important information here. I would like to show this equation on chart, which is right here. Slope y is equal to mx plus b. M is slope 33, and b is y-intercept, which is 1068. So what does it tell me? Every quarter, I expect to have $33 million more of revenue increase on average. So, okay. But another important thing here is to check the R-square value, which says what percentage of the deviation or change in the Y, which is revenue, can be explained by time. And in this case, I can explain 50% of the deviation, which is not horrible, but I would say it is all right. So what I'm gonna do is I can use this slope, 33.18, and this intercept right here to make this forecast. Either you can type those numbers in just like this.
Times x, which is time and plus
y-intercept, which is 1068.9. 1068.9. All right. So this is my forecast, and I could do this way. However, if you don't want to do this manually, what you could do is, instead of using 33.18, you could just use slope function in Excel, which will give you 33.18. So you don't need to create a graph to come up with those numbers. So if I use slope, Excel is asking me my Y dependent variables, which are my revenue values, Control Shift down, comma, and then my X values, which are my quarter numbers starting from 1, Control Shift down all the way till the end of 115, and the close parentheses. So now this is your slope and this slope function. And now I can replace my intercept by intercept function, which is the same thing. I'm going to use exact same y and x. So I will just copy this, Control C, Control V. So now I can calculate the same number exactly same without creating the graph. What I want to do is, though, I want to drag this formula down. To be able to do that, I need to lock my arrays. So I highlight my two arrays here and press F4 to lock them. And then I will do the same thing here. Highlight these two arrays, press F4. And once you do that, enter, you can drag down your formula or double click and right down corner. So these are my forecast values based on simple linear regression. Is it good? It's horrible, 31.1%. Again, our best solution was so far exponential smoothing, 8.28. Simple linear regression ended up being horrible. Why? Again, this is the situation where world has changed because we have probably acquisition in Kraft and Heinz, and my linear regression formula cannot handle it. What if I use not simple linear regression, but if I use some more nonlinear relationships here? So what I'm going to do is click on this trend, and I should be able to see here somewhere right here different options. So if I use exponential option here, you can see that I can explain 54% of dependent variable, which is not a great increase, I would say. So I wouldn't bother to go to exponential by just to improve my R square by 4%. Logarithmic, it's worse, 26%, horrible actually. Polynomial, it is pretty good. Maybe I should use this formula right here. But again, when you use higher power, it just gets harder and harder to understand what's going on in your data. I could even play with the order here. For example, this third order gives me 81% R square. Fourth will give me 81 as well. So it's not improving if I increase so much. So you don't want to keep increasing your order, and because again the complexity rises, and also you start overfitting, which meaning that you will just create a line that fits with your data set, but it's not really can predict the future because you are just literally twisting your model based on whatever data that you have. So if I want to have 100, I could connect all these dots together, but that's not going to help me forecasting anything in the future. So personally, I don't really like to go high orders, but maybe you could consider the third order if you want to, and use this as an equation for yourself. What else do I have here? 81% here. If I use power function, again, doesn't really help. We already calculate moving average, so that's okay. So let me just try also polynomial. What I'm gonna do is I will use maybe I will create a, let me just keep this one linear, and let's create a polynomial. And I'm wondering whether that can beat the exponential smoothing. So what I'm gonna do is, basically before I do that, let me just drag this formula down, and to be able to make the calculations you need to keep increasing this to 100, 16, 17, 18, 20, 19, sorry, so you can calculate these for the future. All right, so what I would like to do is this is my forecast right here. So I would like to use the polynomial for the next worksheet. I will control right, and I will call this one as polynomial regression. So that's also still called linear regression, because you can really take the derivative of that and get the linear version of it and go from there. But I just don't want to go into those details. So what I want to do is try the polynomial regression and see whether my results do improve or not. Sorry about that, my dog is barking in the background. So what I'm gonna do is click on this, and like it polynomial and third order looks like it's pretty good. So what I will do is I will use this relationship. Let me just put the title here so I can copy this. Control C, and then I will just paste that to right here, Control V, and I will replace the x's with my quarter number. Okay, so I will say times, so my x is quarter number. Let me just do it again. So quarter number is equal to my quarter number to the power 3, and then here times My x is gonna be again quarter number to the power 2, and then here again I will replace my x with times quarter number. So now I can drag this one down to see how does this one help to make my forecast. All right, so now you can see that the error here is 14.27%, much better than simple linear regression, 31.59%. However, if you compare with exponential smoothing, it is still not as good, because again, if you see the virtual situation right here, that this situation right here is hard to explain. Here I'm overestimating the reality here significantly. So it helped me, obviously. However, still the best solution is for my data, Kraft and Heinz revenue data, exponential smoothing. That's it for this video. Until next video, enjoy supply chain management.